Good day and a warm welcome on behalf of NTI Audio. Well, what can go wrong with an acoustic measurement? Unfortunately, a lot. And in this webinar, we want to present to you typical traps and pitfalls in a little bit more structured way, and also provide some hints and tips to how to avoid these problems. My name is Markus Becker. I'm presenting this webinar, and I'm assisted today by Paul Sinclair, who is taking care of the incoming questions and comments. Here you see the topics that we have prepared for today. We start with a brief overview on the three main areas where problems can arise. We will dig then deeper into the issue of hardware failures, instrument settings, or environmental impacts. We have also prepared a practical presentation for you, and after that we will summarize the key issues of this presentation and add some more tips and tricks. This presentation is supposed to last about half an hour. Well, there are basically three areas where you can encounter problems that may corrupt or compromise your measurements. The first one is maybe the most dangerous one. If you have any technical problems with your equipment, and especially if these issues are hidden so that you don't see them at first sight. This needs to be avoided, of course, under any circumstance, and we will show you afterwards some ideas, some approaches how to do that. The causes for such defects may be in the microphone, either be it damaged or be it the wrong microphone and the system, the instrument does not know it. But it could also be kind of defects in the instrument itself, in the analyzer. The second area covers the instrument setup. So here some things can go wrong. The input range can be selected inappropriately. Maybe the wrong measurement parameters have been selected, or the logging has not been activated, or the operator has forgotten to start and stop the measurement in time. The third area actually covers environmental impacts, which could be, for instance, a high noise floor, which compromises the accuracy of our measurement. It could be loud incidents or other impacts like wind and rain, etc. So let us take a closer look on these three areas, and we start with the hardware. Here we have to take a very close look at the microphone, because the microphone capsule here at the top of the microphone is probably the most delicate component in your test system. It converts the sound waves, the sound pressure, into an electrical signal. It's an electromechanic device which can be easily damaged if not treated properly. So it can be damaged, it can get wet, it can be dirty, and all these impacts have a direct impact on the accuracy, on the performance of the capsule, which needs to be avoided. The electronics that comes behind the capsule, which amplifies this electric signal, can of course also suffer under problems. This is not very frequent, but it can happen. And of course, also the analyzer itself can show issues like a battery that is down or defective, or maybe the data storage, this SD card in the device is already full, or it's corrupt so that you cannot save the data, or the electronics in the instrument are somehow damaged. This again is happening rather rarely, but it needs to be avoided, of course, as well. So what can we do to avoid, or to at least identify such problems in order to avoid them? Well, the key approach, the most efficient approach, is that you verify the microphone sensitivity with a microphone calibrator. I will show you that later in a practical presentation. But by doing so, you will be very safe that the whole signal chain, all the elements, the microphone and the instrument itself, which are involved in the signal processing, are operating correctly. So this is really the most popular, the most important approach to avoid any hidden problems. Alternatively, you can also expose your sound level meter to a pink noise source and watch the spectrum of the incoming signal. I'm going to show you that as well. This is an alternative approach to verify the proper operation of your system. And the third approach would be to connect an earphone to the audio output of our test instrument. And by that, you can listen to the processed sound signal. So the incoming sound signal, the sound waves, which are translated into electrical signal, are made audible in this way. And if anything goes wrong on the signal path, maybe it's some distortions or whatever, you would hear that rather quickly with your earphone. So this is another way how you can detect potential problems in your test and measurement system. Second area, the instrument setup. Again, we have to take a close look on the microphone and especially on the sensitivity of the microphone. You certainly know that each microphone is an individual device with an individual sensitivity. The sensitivity stands for the ratio by which the microphone translates or converts the sound pressure waves into an electrical signal. So if this sensitivity is set wrongly in the instrument, the analyzer will misinterpret the electrical signal and this will lead to completely wrong measurement results. So it's very important that the sensitivity is adjusted correctly. Another possible problem is if you have selected the wrong input range. For instance, this can lead to an overload, which would be represented by these arrows here. So adjusting the input range to the expected sound level is a very important part. And further on, maybe you have forgotten to activate the logging, which will result in a complete loss of data when you have completed your measurement because they're just not saved on the instrument. Maybe the measurement parameters have been activated incompletely, so there are some measurements missing, and you only notice that after coming back, returning to your office. Or also another problem that might arise is if you have to do a long-term analysis with the LAQ or the LEQ. Of course, you need to start the measurement and you need to stop it in time. Now, this sounds rather simple, but imagine you are responsible for the sound level monitoring of a concert, and you are also responsible for the front of house desk, for the mixing console. This can be rather stressful, and if you forget to activate to start the measurement in time and to stop it, all that you have done is in vain because the measurement will not be relevant, will not represent what was happening during your concert. So summarizing, the countermeasures against these problems are using a so-called ASD microphone. ASD stands for automatic sensor detection. So this means that in your microphone there is a built-in chip, and this chip has all the relevant calibration data inside. It is programmed with the individual performance data of this microphone, and this information can be read by the analyzer. So when you connect such a microphone to the analyzer, you are always sure that the sensitivity is adjusted correctly in the test instrument. If you do not connect the microphone directly to your analyzer, make sure that the cable that is used for in between is also compatible with this ASD technology. So you need a so-called ASD cable. A standard XLR cable would not do the job properly. Next, take a look at the input range before you start the measurement and adjust the input range to the expected sound level. If you are in a very silent environment, you would choose typically the lower input range that you see here on this screenshot. If you are in a very loud environment, you would rather choose the upper input range. Having done all these adjustments, including also the measurement results that you're interested in, make also sure that the logging is set correctly. Here we have seen that the logging is activated. The spectra are also logged. This is a question whether you need them or not. If you are in doubt, just add them. We also recommend, especially for long-term noise monitoring, also to activate the audio logging, which means that you may listen to what has happened afterwards. And if in doubt, always select the all log value. So that means that all measurement results, all weightings, all thinkable combinations will be saved on the SD card and are available for you for post-processing. There are two options. One option is that having made all these settings, you can save them in a so-called profile. And the big advantage here is that if you take your instrument to a special event, like a concert, coming back to that example, you do not have to review all the settings to make sure that they are all set properly. You just open the profile that you have prepared in a less stressful situation in your office, and then you are sure that everything that is relevant is active on the instrument. In addition, you may also use the so-called scheduler. That is a feature that allows you to pre-program the analyzer in a way that it automatically starts the measurement and stops it when you have on the moment when you have foreseen that. So for instance, when you know that the concert starts at 8 p.m. and it ends at 10 p.m., you can pre-program the analyzer that it automatically starts and stops at these two times, and you don't have to care about it. Now, I need to do a short sidestep, a short side note on the sound level calculation. And this is in order so that you better understand why it is recommendable to save all feasible, all possible measurement data on the instrument. Here we see schematically the process of measuring sound level. We have a microphone that picks up the sound waves. The output signal is transferred or translated into a digital data stream, 48 kilo samples per second, so 48,000 samples per second. This is the raw data which is used by the instrument for all following calculations. This raw data will not be saved on the SD card. This wouldn't be feasible just for the sake of data volume. But this raw data plays a very important role because based on this raw data, the instrument calculates the time weighting here, the fast, slow weighting, the frequency weighting, Z, A, or C weighting, and also it allows the instrument to chop these samples into time slots depending on the settings from the customer. Maybe if you need a 100 millisecond log interval, the analyzer can do so by applying this time chopping here in this on this raw data. So all these calculations are done on the instrument. This is very important to understand because as a result of these calculations, you get all the measurement data that you're looking for. But it is important to know that some of these results cannot be post-process. For instance, if you want to know the A-weighted wideband level and you have forgotten to activate the A weighting during the measurement, this cannot be reconstructed. You cannot afterwards in any way recalculate the data, the available data, in order to get the A-weighted wideband level if you have only the Z-weighted available. So for that reason, it's really recommendable to save all these different results on the instrument, especially because the SD cards typically provide enough memory for this amount of data. So coming to the third aspect that I mentioned in the beginning, the environmental impacts. Here we have, for instance, strong wind. Strong wind is not only howling around the corners, but when it hits the microphone capsule, it will create sound events or sound-like events that are actually not real sound events. It's just the wind that creates these events, and that will compromise the accuracy of your measurement. Same applies for rain or humidity, which may compromise the accuracy of the measurement. A different incident would be short noise incidents, because they may not correlate to what you're looking for. Let's assume, for instance, here we have to measure the noise coming from that street here, and there is a thunderstorm, and the thunder, of course, makes noise and it adds up to the overall sound level, but you're not interested in the noise level from the thunderstorm, but only from the street. So somehow we have to eliminate this thunder afterwards, after we have recorded for a couple of days or weeks even. And a third problem that may arise is, let's assume you need to measure the sound level of this machine here, but there are other machines standing next to it and making noise. So how can you be sure that your measurement is really representing the noise coming from this machine only? In a loud environment, this is hardly feasible. But what can we do about that? First of all, coming back to this strong wind and the rain, it is mandatory, especially when you place your microphone outdoor, to apply a windshield. And if the microphone might be exposed to rain, of course, also the weather protection is mandatory, because otherwise you would destroy, or the rain would destroy your microphone. Please keep in mind that when the microphone with the protection is exposed to direct rain, you cannot measure during that period, because the raindrops are causing noise when they fall here on the windshield, and that is, of course, a very special noise that has nothing to do with the environmental sound level that you are looking for. Furthermore, as stated before, we recommend to record the audio file, because that allows you afterwards, after completing the recording, to identify these single events like the thunder and to eliminate it, in order to make sure that your measurement result will only respect or reflect the situation from the road and not any external events like thunder. And last but not least, coming back to this example here, when you have to measure in a noisy environment, you must make sure that the noise, the sound from your target source, is minimum 10 dB higher than the noise floor around. This is a rule of thumb, and it just tells you that when you have the situation, you can be quite sure that the measurement result is sufficiently accurate. If this distance between the noise floor, or the headroom between the noise floor and your target source, is less than 10 dB, then it means that the accuracy of your measurement is heavily compromised, and it's questionable, more and more questionable. Well, that brings me to my practical presentation. I have here a talk box opposite to a M2211 microphone, which is connected via ASD cable to my analyzer. And you can see the screen content of the XL2 by using the XL2 Projector Pro software. By the way, you see the setup on the right-hand bottom corner in the small thumbnail. So let me switch over to the Projector Pro software. And the first thing I want to point out here is this small entry, these 3 characters ASD, they indicate that the analyzer has recognized the connected microphone as an ASD capable microphone. It has read the sensitivity from that microphone, and that way you are sure that the displayed level here is absolutely correct. Second, I want to show you the test that I was emphasizing so strongly with the microphone calibrator. So I will put the microphone calibrator, you can see that in the small webcam picture. Oh, sorry, I made one fault. I need to just replace the microphone capsule first with a good working one. So now I'm going to put the microphone calibrator on it. And you see the result is 114 dB. So that's exactly the sound pressure level that's being created by this calibrator. And this way you are pretty sure that your system is working correctly. because if it had any problem, you would immediately see a deviation from this result here. Next, I want to show you the calibration screen. On this screen here, you see all the relevant information that has been read from the microphone. You see the sensitivity, the currently active sensitivity from the microphone. You see down here the microphone type and the serial number of the microphone. And you also see the difference between the original calibration value and the current calibration value. So this difference is quite important, because if it gets too high, if there is a large difference between the original calibration when the microphone was manufactured here in-house and your measurement here, your calibration result, if this difference gets too large, this is a strong indication that something is wrong. Here we have just 0.8 dB difference, which is pretty low, which is acceptable because there's also a minor drift. But if this difference would be larger than 1 dB or even more, this would be an indication that something is wrong. Well, let's get back to the logging screen. I want to show you that as well. Here, logging. And you can see I have activated the logging. I could deactivate it, which would not be very smart, so I leave it active. I have decided to add the spectra. I could disable that if I don't need them for sure. Here I have activated the audio file recording, and I have selected values recording recording and saving all measurement values. I could change that to a selection of 10 values, which I have to manually edit. So here there have only 4, could add more. Just keep in mind, if you are absolutely sure that these are the only 4, for example, that you need, then you're fine. But if you are insecure, I would definitely rather say activate the all mode, because then you're sure that you will not miss any relevant information. And also, here, if you go to the autosave mode, this will tell you that every measurement, when it is completed, will be automatically saved on the SD card. That is when it is on. So you don't have to worry about that. It will be saved with an individual name. You can also change it into assisted. Assisted means that the instrument will tell you to confirm the saving, but it will also give you the chance to edit the name of the saved file. Maybe this is of importance for you, then you can activate this. The third mode would be autosave off. Not very recommendable, because if you forget to save the results manually, they are lost. So either on or assisted are our recommendation. Then, having made all these settings, we can go to the profile feature down here. So when I confirm and I go to manage, so here I can save my data, my current settings as a profile. I won't do that right now, but this is the way how to do it. I can import predefined profiles from the SD card, export them. Anyway, this is the way how to save or even delete, if you like, the profile. When I want to load a profile, I go again to this menu here and I just say select. And now these are the profiles that are available on my instrument. These 4 here are predefined profiles representing national standards. And here are 2 custom profiles that we have defined. So you can define them yourself and activate them whenever you need them. And the third point here, the system settings. Here we have the scheduler. Here you see I can define the start time, date and time of my recording. I can define the duration. I can define on which day, or maybe whether the measurement shall be executed repeatedly on several days, and so on and so forth. All these settings can be made here on this screen, and by pressing the start button down here, the instrument will be armed in terms that it will execute this schedule as programmed. Okay, get back to my screen, and now I'm going to show you this alternative mode of verifying the operation of your microphone with a pink noise signal, and I'm switching here for that to my Octave screen. Now I will activate pink noise signal and let you, you can then see the effect here on the spectrum. I guess you noticed it's a pretty flat frequency response here in the mid-range, and the microphone seems to be working fine. So let me replace now my capsule with a definitely defective one, and you're going to see the impact of this defective microphone capsule immediately, because the picture, the spectrum, looks completely different. So I'm going to reactivate my pink noise. I think it's quite obvious. This frequency response was not flat at all, indicating that something's heavily wrong with this microphone capsule. And now comes my third presentation, and this is another capsule, and I'm using that for showing you the impact of a water drop on the microphone membrane. Now, to see the impact, please watch the frequency bar here to the right-hand side, the 16K frequency bar, because here you will see most clearly the effect on a water drop on the membrane. I guess you noticed how this bar dropped immediately, visibly, as soon as I put my water drop on it. So apparently this water is inhibiting the proper operation of the microphone in terms that it is dampening the high frequency result. And this is, of course, something we don't want to have in our measurement result, because all frequencies are equally important for the correct measurement. Good. So let me switch back to my presentation and summarize the key messages I want to give you. Please regularly verify your equipment. This is a short investment you can do, and it has a huge impact, huge benefit. You can do that in-house with a microphone calibrator. You can use a talk box if you have one, as I showed it just to you. You can just use a earphone plugging to the instrument to listen to the incoming signal. Or if you have a noise gate system and an XL2 with M2340 microphone, this is the latest microphone from us, you can even execute a self-test, a remote self-test with that system. Alternatively, you can, of course, send the unit to us or any of our service partners worldwide. We have a very convenient procedure for that. You find that on our website. If you go to support, calibration, and service, it's a nicely explained step-by-step procedure to send your instrument to us and get it returned calibrated. We also recommend to prepare a checklist for your on-site measurements so that you don't forget the important steps. Be the microphone okay, input range adjusted, are all the measurements that you need and the logging active and so on, and have you started the measurement? So this is a good help, a good aid, such a checklist, not to forget anything. And last but not least, talking about documentation, it's not just about collecting the data and saving the measurement results on the SD card. We also recommend to document your work with a photo, maybe several photos that show the measurement setup, because this will allow you also afterwards to prove that you have done everything right, or to possibly identify potential problems in the background. And same applies for the notes that you're taking. You can do that in writing, or maybe a voice note on the instrument. The XL2 also supports the recording of voice notes. So this is also can be very helpful for your work. Well, I'm at the end of my presentation. Me from my side, thank you very much for your presence, for your attention. I hope I was able to provide the information you were looking for. And of course, I would be very happy to welcome you again at one of our future webinars, for which you will receive a corresponding invitation. For the time being, thank you very much. Stay healthy, have a good time, and bye-bye.